Hello wonderful person, this is Anton, and a few years ago I made a video where I tried to create this beautiful ball made entirely out of planetesimals, basically smaller objects like Ceres and Vesta that with time created this beautiful planet. Now this was using a slightly older theory. Today we're going to do the same using the new understanding of planetary creation. Anyway, welcome to What the Math. So if we were to deconstruct our planet from scratch, from how it used to be a long time ago, it was basically made out of these chunks known as planetesimals that you kind of see flying away right now. These chunks though didn't just come from the solar system out of nowhere. They didn't just form themselves from asteroids or from dust. They did actually appear in a very peculiar manner, and today we're going to be investigating this using some of the newer theories on the creation of our solar system. So back in the days when the solar system was all new and the sun was kind of still finalizing its early stages, there was basically a lot of dust flying around it. And so here you can kind of see all of this dust ring flying or orbiting around the sun, and with time it's going to start accumulating and creating these smaller objects known as planetesimals. But we originally thought that a lot of the terrestrial planet stuff was a little bit closer to the sun, and a lot of the icy particles and methane and water was on the outskirts. And as the planetesimals here started colliding, they created terrestrial planets. As the planetesimals here collided, they created the gas giants. Today we think it wasn't as simple as this. Today we think that, well, first of all, based on observation from other stars, we discovered that there seem to be a lot of these stars, as a matter of fact, majority of stars that have these so-called super Earths. Now, a good example of a super Earth would be Planet 9 that we think exists somewhere out there in our solar system. This is basically an object that's anywhere between 2 to 3 masses of Earth to possibly even 17 masses of Earth, essentially similar to a planet like Uranus or Neptune. These super Earths are very common out there. As a matter of fact, the majority of stars we've discovered have them. Our solar system doesn't have them. And so what we think today, and this is from the last few years, as of 2017, is that we had these super Earths. We had a lot of them. We had tons and tons of them orbiting around the sun. Well, okay, not tons and tons, but at least, I don't know, 5 or 6 maybe. And they were there just like in other solar systems. But with time, what started happening is that something caused them to collide and to basically then, okay, I don't know what's happening here, but they're flying away everywhere, but to then basically destroy each other, destroy themselves. Now we're going to simulate this a little bit differently. We're actually going to create a new system here. Just like in the previous video, we're going to make a miniature solar system with the sun in the middle and a few super Earths, specifically Planet 9 here, orbiting around it. So these will just stay here for a while, and now we're going to think about what could have happened that basically changed their orbit and made them collide with each other. And we might actually place a few more just because we want to actually increase the chance for their collision. Well, we think that when Jupiter was created, because of all of the dust in the solar system, it slowly started approaching the sun from the region where it was originally created to as close as the distance to Mars. So it may have actually been this close. For this simulation, we're actually going to place it right here. Now, Jupiter is an extremely massive planet. It's like 318 masses of Earth, and it influences our solar system dramatically. And so here, placing Jupiter in this location will very, very likely start changing the orbits of these beautiful super Earths in the middle. And now we're gonna just wait and see what happens. Now, because these are not entirely made of just rocks, they're actually made of gas and rocks. These are super Earths that could be gas giants, essentially, just smaller gas giants. We think that their collisions created a lot of material. There's collision number 1, you could see it happening right there. And so when they collided with each other, they created tons and tons of rock, tons and tons of planetesimals, but also, of course, gas and a lot of materials that probably then either got released into the outer solar system and got absorbed by planets like Jupiter and Saturn, Neptune and Uranus, maybe created comets and other objects, or maybe fell into the sun. But it's also possible that one of these, Planet 9, actual Planet 9, escaped into the outer solar system and is still there today. So maybe, just maybe, this is actually where our super Earths went. Now, we're going to wait for a few collisions to occur here, and we're then going to investigate if any of these will turn into actual terrestrial planets, because this is what we're trying to create here. You can kind of see their orbits changing already. I need to accelerate this a little bit more. But as their orbits change and as they collide with each other more and more, they're going to start creating a lot of material here that is then going to essentially hopefully create some terrestrial planets, and maybe, just maybe, one of them will look just like Earth. And this is what we're hoping to do here. So I'm going to just run this for a few minutes, hope for some more collisions. There was just one that occurred right now. You could see it because the game slowed down just a little bit. And with more and more collisions, there's going to be more and more unusual objects created. And here's actually a better view of how these orbits are changing. You can kind of see with time they start wobbling, they start changing both the periapsis and apoapsis and eccentricity. And so this creates a lot of opportunities for all of these super Earths to collide. Now, a lot of them already have collided. We're going to check what happened to them in a few seconds. But right now, I just want to see if at least one of them might actually escape into the outer solar system to create the actual Planet 9. So we're going to accelerate this a little bit more. There's a high chance that one of them is about to do that. And maybe, just maybe, it's going to happen sometime soon. And well, just like that, about 16 years after I started the simulation, at least one of these planets got kicked out to the outskirts of our solar system. Not as far as you'd expect it just yet, but maybe with time it will get even more kicked out. So it's kind of, has this very elliptical orbit. It has very high semi-major axis compared to other planets, and it possibly is going to stay on the outskirts from now on. The other planets actually either collided with each other or combined with Jupiter, and so for the most part, most of them collided quite dramatically and quite a lot. I actually had to add a few more of these planets just to have more of them interact with each other. But if I run this, you'll notice that within just a few minutes, a lot of them will actually collide with each other and combine their masses. Now, because this is not exactly what we're trying to do here, we're not trying to combine them into a large planet. Let's just decelerate time a little bit and see what happens when one of these planets collides with another. So there comes our first collision between two Planet 9s that are relatively close to each other. Now in this case, they kind of just really combine with each other, which is not exactly what would have happened. So maybe, just maybe, we need to actually go and do this as a separate simulation between two super Earths. Here we're going to pick Gliese 876d and once again Planet 9, and we're just going to launch one at another and then just see what actually happens as they collide with each other. So essentially, when these two objects collide, they're going to create a tremendous amount of material. There's going to be obviously a lot of gas and a lot of rocks and stuff, but for the most part, all of these fragments will then start coalescing into the planetesimals. Now, what happens to this huge chunk, we don't really know. It may have fallen into the sun, it may have been kicked out by Jupiter, or it may have actually joined or got absorbed by Jupiter. But this material, these fragments right here, they will be combining into the planetesimals. And so if I go back to the simulation I just created, what we'll end up having is a bunch of material, including very large super Earths and a lot of various terrestrial planetesimals just orbiting around. And with time, all of this rocky material will combine into planets very similar to Earth, Mercury, Venus, and Mars. Now, if I run this long enough, it will happen naturally. I will have to run this for many, many years, but you can see the collisions are already occurring. So there is a collision right there that's going to kind of cause some materials to fragment and create particles as big as 13.2 Earths. This is very, very large. And here's a particle that's only about one Earth, and we can actually even turn this into full body. And so just for the sakes of making this a little bit more interesting, let's convert all of these to full bodies, which means that they will now be detected by the game as actual particles and not as just fragments. Now, we're not going to do all of them because that will just make my game unresponsive, but we'll do a lot of them as bodies and just watch what happens. So a lot of these will not disappear anymore, they'll actually stay as fragments. And this kind of shows you how even a single collision would create a tremendous amount of material, tremendous amount of fragments, huge amounts of material for planetesimals. And with time, these fragments and these planetesimals created Earth, Venus, Mercury, and Mars. Now we're gonna run this for a little bit, and let's see what comes out of it at the end. So a lot of these larger objects, like this one right here, will probably not really stay around for too long, but many of these fragments will remain in orbit and turn into planets. So we're just going to run this until something interesting starts happening. And here's how all of this craziness of early solar system looks like with like 17 hours per second time. So basically a lot of this was due to the Jupiter's close approach. And by the way, Jupiter later on got pulled back by Saturn and moved to its current position. But when it was closer to the sun, it kind of caused a lot of craziness in the inner solar system. And following this craziness, which we're going to see in a few seconds, there were only a few survivors, and many of them turned into the planets we have today. So this is just a few hundred days later. Some of the objects disappeared, some of them are still here, and for the most part, you can actually kind of see what goes on here in terms of orbits. So there's still quite a lot of craziness going on. This is not a finalized solar system just yet, but let's actually enable labels and check out some of these objects as they are orbiting the sun. So a lot of them escaped the solar system. Some of them will end up on the outskirts of the solar system and possibly become Planet 9. But the ones closer, the ones right here, the fragments that are currently orbiting around our sun, are going to coalesce into the terrestrial planets. So there's going to be Mercury created here, there's going to be Venus, Earth, and Mars. And the other fragments, the ones that stay orbiting around, will very likely then turn into the asteroid belt. And just to accelerate all of this, let's place Jupiter a little bit closer right here and make this a slightly more chaotic system. So let's see how Jupiter actually rearranges all of this and makes these fragments behave with time. So as you can see, because of Jupiter, the craziness increases even more. The fragments start flying around all over the place, and there's actually quite a lot of collisions on the inside as well. And so let's just kind of run this for maybe a few years of in-game time, just to find out what happens to all of these objects at the end. And so just after maybe 4 or so years of in-game time, let's actually see what happened here. So let's see what kind of fragments we've created, what kind of planets we've created, and if any of them resemble Earth, Mercury, Venus, or Mars, or if any of them resemble anything else in our solar system. So we could basically look at them individually, or we can just go into the charts here and take a look at some of these just side by side. So there's the Jupiter, Some of the fragments are still hot because they're so close to the sun. But right here we have a very interesting object. It's 2.4 masses of Earth. So technically this is actually still a super Earth. Now, whether this is something that's going to fall into the sun later or not is another question. But for now, it still is there. So we don't really know what happened to these objects. Maybe they've survived, maybe not. Here is a very interesting object. It's actually hot, but that's because it's so close to the sun. It will at some point reach a farther orbit because I did place these a little bit too close, mostly because I wanted to have collisions faster. But the total mass here is almost Earth-like. It's 98% mass of Earth, and its materials are very Earth-like as well. Something like 15% iron, 80% silicates, a little bit of water, no hydrogen. So this is actually potentially a very Earth-like object. I can even maybe rename it Earth. Let's look at the next one. This here is also very Earth-like. This we could call Venus because it's a little bit less massive than the Earth we created. Next object is even less massive, so maybe, just maybe, this is either Mercury or Mars, although it's maybe a little bit too close to the actual mass of Earth, because Mars and Mercury are significantly much lower in terms of mass. And there's actually 3 more objects that are very Earth-like. And then we reach the objects that this is actually very Mars-like. This, as a matter of fact, this is almost Mars-like. So maybe we can name this one Mars. And in terms of the actual, oh, okay, yeah, this is a little bit too much iron for Mars. So maybe this is more like Mercury. And this here could be Mercury because it does have a lot of iron. The other objects are also very kind of similar to fragments that we have in our solar system. Some of them are actually very similar to Ceres and Vesta and other asteroids. But as you can see, there's quite a lot of these fragments that are out there still. Now, if we go back to the actual solar system, this is what it currently looks like. So you can kind of see, because I renamed some of them, you'll see the Earth in there, you'll see Mars, that's right there, Venus. Now, obviously, these will eventually change their orbits and will circularize their orbits and will assume new positions. But for now, this is the mass that we've created because of Jupiter and because of all of those collisions with the planets, the super Earths that I placed in this region. Now, this was an extreme sort of simulation of this theory. But if I were to run this with more realistic masses involved, and if I were to run this for like millions of years, at least in game time, you would actually see something that would look very similar to our own solar system right now. This has been done by scientists, and they've actually showed this very realistically using various simulations. So the initial super Earths, their collision leads to the creation of these fragments that you see right now. These are the terrestrial planetesimals, and these will then collide and create Mercury, Venus, Mars, and Earth. So this is currently the best available theory to us that explains how Earth was created. Maybe in a few years we'll have something else, maybe we'll know a little bit more about our solar system, but for now that's all we know and that's all we think happened. Anyway, thank you so much for watching, thank you for all your support, space out, and as always, bye bye. And before I go, I actually wanted to thank Brilliant.org for becoming the official sponsor of this channel and for providing me with a lot of really cool topics to teach, to study, and to basically help you guys with as well, because it's a website that teaches you quite a lot about sciences, math, and a lot of other topics as well. Do check it out. It's a very cool website. The link for this website is in the description below, and they do offer a variety of problem-solving tools that help you become better at pretty much any subject that is usually very difficult. Unlike other similar websites, this website actually offers a well-developed series of guided problems on a variety of subjects, including physics, math, computer science, finance, and topics that you may find difficult at school, but they explain really well. Most importantly, I like how they do things with active learning, and I really appreciate the amount of material they've already created and the amount of easy to understand topics, or I guess hard to understand topics, that they made so much easier to understand. Anyway, do check them out, building.org. Thank you so much for your support. I'll see you guys tomorrow. Space out. And as always, bye bye.